Hi, I'm Benedict. I'm a co-founder of Foursquare Tutoring, and this is problem 16 from the 2023 AMC 12A. What we're given here is this magnitudinal equation in z, and we want to find out what the maximum value of the imaginary part of z can be if it satisfies this equation. So with magnitudes, they are kind of restricting. There are not too many properties you can use with them. And I really want to use the simplest one, which states that magnitude of A times magnitude of B equals magnitude of A times B. Once again, you can try and prove this for yourself. You could do A plus BI times whatever and see what happens when you write it out. But how can I use this magnitude property with a polynomial? Well, the obvious response is just to factor it. And we can still do that here even though it's not a quote-unquote factorable polynomial. So the roots of z squared plus z plus 1 are the third roots of unity except for 1. So they're e to the 2 pi I over 3 or negative 1/2 plus root 3 over 2i and negative 1/2 minus root 3 over 2i. So when we factor this into its roots, we're going to have z minus this times z minus this. Or, writing this out again, this is z plus 1/2 minus root 3 over 2i times z plus 1/2 plus root 3 over 2 times I. Magnitude of the whole thing is 4. Split this up into its individual parts. This is z plus 1/2 minus root 3 over 2i times magnitude z plus 1/2 plus root 3 over 2i equals 4. Now we want the imaginary part to be as big as possible, so the real part has to be small as possible. This is because the real part squared plus imaginary part squared has to be 4. Now luckily we can actually make the real part 0 for both of these, just by making real part of z equals negative 1/2. Then z is negative 1/2 plus bi, and we can see if we substitute this back in here, a lot of stuff will cancel out. So the real parts go away, which means we're left with bi minus root 3 over 2i, magnitude of course, times bi plus root 3 over 2i. Is equal to 4. Now we can factor an I out of both of these, and remember that the magnitude of I is equal to 1, because we can just look at the complex plane, and also almost by definition it's true. So the i's don't even matter. Factor them out, they're 1. This means we have b minus root 3 over 2 times b plus root 3 over 2 equals 4, or magnitude of b squared minus 3 over 4 equals 4. Now we could take the plus or minus solution of this. Now to maximize it, we will just take the positive one. That means we have b squared equals 4 plus 3 over 4, or 19 over 4. B, once again taking the positive solution, that means b is square root 19 over 2. This is in the form root m over n. So m plus n is 19 plus 2, which is 21.